Hey, Homo sapiens, it's Miss Garcia coming at you. It's been a while. So, today we're going to be talking about natural selection and a little bit of recap from evolution. So, let's get to it. Evolution. So, you should have picked up a little bit of this from, or a lot of bit of this from last week's video, What Darwin Never Knew. Evolution, all it is, it just means a change in population over a long period of time. So, it's not about an individual changing. A squirrel won't just change from a light color to dark color overnight, like one individual squirrel. The entire population might shift over an extremely long period of time. So this is my example that I was talking about here. So you have a population of the green represents a gray squirrel, and it's the same species, right? And there's two color variations, and then the red represents a black variation. Well, maybe that black variation was more favorable, and they were more likely to survive the next generation and pass that forward. And so eventually the population might start shifting to becoming darker in color. But again, it's not one individual that changes overnight like that. So if you watched that video, you learned a lot about Darwin. He was the father of evolution. And so evolution, you saw, was a theory. And the reason it's a theory is because it doesn't happen overnight. You can't see it with your own eyes. So to this day, it's still a theory. It's got lots and lots of well-supported evidence, but can't be proven as a law yet. So some of Darwin's observations that led him to come up with the theory of evolution is he was like, hey, there's variation between all these populations. There's within the same species of squirrel, there's a few different colors. So he kept noticing this variation. And then he started noticing some variations are favorable, meaning that they were more likely to survive than the other variation. And then he realized too that not all young produced in each generation can survive. And so the individuals that survive and reproduce are the ones with the favorable variations or traits. So he also found that living things share common ancestors, basically saying we're all once upon a time related. We all have common ancestors if you keep on tracing back in our evolutionary past. Over time, evolutionary changes will eventually give rise to a new species. So you saw that with his finches on the island, is that there was probably one original ancestor finch, and then based on pressures of the islands and different food sources, changes gave rise to new species. All right, so what is this natural selection business? Natural selection is the process by which change and evolution occurs in populations. So basically what we're recapping, organisms with favorable traits will survive, reproduce, and give those favorable traits to future generations. Basically, another word for that, or a little phrase for that, is survival of the fittest. I don't know if you've ever heard that, but what fittest means, or fitness, is based on your reproductive success. So the more fit you are, the more likely you are to reproduce and pass on a trait to a future generation. So that might not make sense without some examples, and I'll give you some here. So in order for a species to survive, it's got to reproduce. The more members of the future generation that have beneficial traits, more members of the future generations will have the beneficial traits as long as the environment stays the same. But sometimes that's not the case. The environment will change. Those are called selective pressures. So this is an example of a couple different color variations, we'll just say in a random species. And after selection, what was the selected trait? Was red. That was the most favorable trait. And so when these two organisms reproduce, of course, they're going to pass on that favorable trait to a final population. Let's see that example in beetles. So let's say this is the first generation of beetles, and these crows, they really like to get down on the green beetles for some reason. And so the red ones are going to be those, or orange, I guess, going to be those who are more likely to survive, and they're going to reproduce and pass that trait of being orange onto future generations. And eventually the population will start to shift in that direction. And that, my friends, is natural selection in a nutshell. There's also artificial selection. So as humans, we use this a lot as our benefit. So natural means it happens in nature. There's no one, basically the environment controls that. But artificial selection is something that humans control. And so we started doing that with anything from dogs to agriculture. So dogs, all these dogs, basically ancestors of wolves. And what we as humans have done is we've selected traits that you wanted within the dogs and started to breed for them. So maybe like Chihuahua, people wanted a dog that was able to sit in their lap, so they started selecting the favorable trait of being tiny and small in size and things like that. Or the opposite with Great Dane. You probably wanted to select a larger size and breed for that. We do the same thing with agriculture. So cabbage, Brussels sprouts, cauliflower, their ancient ancestors looked a lot more like this. We've selected traits that we liked about them. So same thing with corn, even chickens. So if you were to go back 50 years in the past and see what chickens that we used to eat looked like, they were a lot slimmer, thinner, smaller, and now we're starting to selectively breed them to be thicker, larger, carry more breast meat to where they can hardly walk. But again, those things are for our benefit. That's artificial selection. So now that we talked about evolution, what's leading towards evolution? Like, what's the cause? So some of the causes are genetic variability, so from mutations. And then if there's a limited supply of resources, you're going to start competing, and favorable traits will win, survival of the fittest. Also environmental pressures. So there could be a change in the environment that causes somebody to be more fit than others. Ooh, have y'all ever heard this one before? Antibiotic resistance. So a lot of bacteria nowadays are becoming resistant to antibiotics. So what happens is you have a high number of bacteria and a few of them are resistant. Maybe they became resistant through, say, like a mutation or something like that. So say if you have a bacteria infection and you have some bacteria in there that have a mutation that make them resistant to antibiotic, you take the antibiotic, it kills all the bacteria except for, look, these two little orange bacteria here. They were resistant to the antibiotic. And so what's going to happen is they're going to reproduce, and all of their future generations would be resistant as well. So eventually the population of that type of bacteria might become completely resistant to that sort of antibiotic to begin with. So an example of that, have you guys ever heard of staph infections? So MRSA or staph infections, that is a bacteria that is nasty, and it is, I say nasty because it's highly resistant to a lot of antibiotics. So we've been trying for decades to eradicate this bacteria or to be able to treat it with antibiotics, but it's evolved and changed so much that it's basically become resistant to everything that we treat it. So if you've ever got a staph infection, like some sort of wound that got a staph infection, it takes a long time usually to get rid of it, to find the right combination of antibiotics that it's not resistant to get rid of. Well, all right, friends, that's all I got for you with natural selection. You guys are gonna do a little activity later this week to where you're gonna play the role of a bird eating the peppered moth. And so if it didn't make sense now, it should definitely make sense after you do your little peppered moth lab. It was good to see you. We'll see you soon. Bye.